Okay, we're going to go ahead and get started. And what we're talking about today is embracing the digital twin. Now, just to take a look at our agenda, we're going to start by briefly talking about who Geometric Solutions is and how we can help you. And then we're going to dive into part two of embracing the digital twin, looking at will your machine work as designed? In part one, we talked about what would you do if you could not fail, or what would you make if what you made could not fail. Well, in part two, we're going to actually get to see this put into practice. If you didn't attend part one, well, don't worry. We're going to have a QR code at the end that you'll be able to scan, and that way you can see both of the parts in order. My name is Dan Turk, and I'm an application engineer with Geometric Solutions. Now, briefly about Geometric Solutions, we're part of the WALTONEN family of companies. So Geo, we sell Siemens software solutions. WALTONEN has hundreds of engineers that use those software solutions. And then Independence Tooling, we have a facility that the things that are being designed and created, well, they're being built there. So you could say from A to Z, we've got it covered. The owner of our company, he put it nicely. Our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. So we're not just selling tools, no, we're using them and using them effectively. So let's jump in, embracing the digital twin. And the tool that we're going to look at specifically is called Mechatronics Concept Designer. This is an excellent tool for machine builders. Now, just to set the stage, what is the digital twin? Well, the digital twin, you can see the quote right here, or the definition. It's basically taking all of the real things and making them digital. It's not just taking a CAD model, or it's not just making a cartoon, but it's taking the physics, the electronics, every little bit of it, and then running a digital twin or a digital simulation. Now, why is this something that a lot of folks are interested in today? Well, simply put, digitalization, it is changing everything. Gone are the days when you would just create a machine, it would all be mechanical with just a couple of cylinders, no electronics. Yeah, those days are gone. Now we have PLCs, HMIs, and the list just goes on and on. So how can we take this real world and the digital world and bring them together? What we do with virtual commissioning using the digital twin is we take all of the mechanical bits. So that would be the kinematics, the robot programs, all those pieces. And then we take the electronic portion. So it's the PLC, all the IOs, the HMIs, and so on. And we take and marry those two together. And then what that gives us is virtual commissioning. Now, everybody knows what real commissioning is, right? When you're standing in front of the machine, you've got the HMI in your hand and you're hoping everything works. Well, we do that virtually. And this gives us this integrated environment that lets us test the mechanical behavior, but also the electrical behavior. You'll notice part of that electrical behavior, here's an HMI, so it has to do with making sure the PLC code is going to work. This simulation, it happens at every level. So in the real world, you've got the HMI, it's hooked up to the controllers, which are controlling sensors and actuators, and all of that put together, and you have this machine. In the virtual world, it's the same thing. It's a virtual HMI, controlling virtual controllers, hooked up to virtual sensors and actuators, controlling a virtual machine. So it's allowing us in a virtual environment to validate, to test, to make sure that our machine will not fail. Now, what's nice about this is it gives us some scalable solutions. Now, if you think about a typical workflow, we always start with the idea. And then after we have the idea, we start making some conceptual designs. And as the conceptual designs, as they grow, well, then we get the real machine. Well, we can do the same thing when it comes to writing our PLC codes, that as the design goes from concept and starts to mature, our PLC programming can be done the same way. We don't have to wait until the machine is actually built to do all of the commissioning. You can just imagine how much time this is going to save. Now, there's two different ways that we do our virtual commissioning. There is software in the loop and hardware in the loop. And we're going to discuss each one of those. So let's see how this works. First step, software in the loop. So we start with a mechanical CAD model. It can be NX, it can be SolidWorks, CATIA. It doesn't matter what type of CAD model it is. Any CAD model. We bring that into NX Mechatronics Concept Designer. And then we do some work within that program. Then it comes to our automation. Now in this case, we're going to be using the Siemens version. So we have everything virtual using the TIA portal. So it's virtual PLCs, HMIs, safety, virtual everything. And then we hook up all of that programming into a virtual PLC. And that is what gives us software in the loop. So on one computer, if you wanted, you can have the mechanical model, you can have the virtual PLC, the virtual HMI, safety, the e-stop, everything contained on one computer. That's what we call software in the loop. This again is the Siemens solution, and we feel that it's the best in class solution. But you might think, well, some of our products that we're working on, it's the customer that decides. And sometimes the customer wants a Mitsubishi PLC or an Allen Bradley or Omron. If that's the case, no problem. We would just use what's called a hardware in the loop solution. How does this work? Well, it's very similar. We take a CAD model, again, any CAD model, it doesn't matter where it's coming from, SolidWorks, AutoCAD, bring that into Mechatronics Concept Designer. Now, here's where the hardware comes into place, because we're actually going to take the real hardware, so a real PLC. Then we connect that real PLC to NX Mechatronics Concept Designer via a OPC UA server. Now that's just the most common language, and it makes it so that they can talk to each other. This gives us a hardware in the loop solution. So on our computer, we've got NX Mechatronics Concept Designer. We've got that model that we're commissioning to. And then we have the hardware. So hooked up to it, maybe with an Ethernet cable, we've got the PLC. Hooked up to that, we might have the HMI, safety, e-stop. You get the idea. Here's a picture of hardware in the loop. So the gentleman that made or took this picture, and we're going to see this demonstrated in just a moment. You can see on his computer on the left, there's NX Mechatronics Concept Designer. On the right, in the background, we have Rockwell's Logix Designer. And then in the foreground, we're still using a Siemens virtual HMI, but you could use a different one. And then there's that hardware right in the loop. So it's using that Rockwell PLC. So again, this is hardware in the loop because the hardware is literally in the loop. So you could think about it as virtual commissioning and done two different ways. Now in each one of these videos on the left and the right, we're getting the same result. On the right, there you can see our ladder logic, and as things are moving on the model, you can see it fire up. On the left, with the TIA portal, you're seeing the exact same thing. So it's virtual commissioning done two different ways. That's what's so powerful about this tool. If you're using Siemens, well, it's all contained in one computer. If you're using hardware in the loop, because you have a different type of PLC, it still works. You can still do your virtual commissioning. Something else that we can do is virtual training. Now I know that if I'm holding an HMI in my hand, or really anything that has buttons, it's the red shiny button that I just can't resist. I have to press it and see what happens. Well, there's sometimes a little bit of a panic there that we're handing our machine over to these operators and we're just hoping that nothing goes wrong. Well, imagine being able to train them virtually. Now, the example that we have here we've got the HMI that you can hold in your hand. There's that shiny red button. Well, if you press it, nothing bad is going to happen because you're running this training virtually. So on the screens, you're actually able to see what the machine is going to do. Imagine being able to train your customers before the machine is even shipped. Imagine how much faster they're going to be able to get their product out the door and make you their preferred supplier. When it comes to this tool of NX Mechatronics Concept Designer, there's a lot of powerful things that it can do, right from the concept all the way to the detailed design portion. What's nice about this is it has a really powerful physics engine, so that when you're running this, gravity is actually pulling on your models. We can use this tool to find out cam curves, but then we can also use it to create a sequence of events. And we'll look at each one of those. Now, for an example, we're going to use this little machine here made by Delta. Now, there's a couple things I want to point out. Number one, this was not an NX file, so it's not from Siemens. Now, what they use this machine for is kind of like a traveling roadshow. So they take it around the country to different places. You'll notice there's a lot of electronics that are going on with this. So it's not just a mechanical, but lots of electronics. And what this machine does is it tests bottles' integrity. Now let's see how we can use NX Mechatronics Concept Designer. First, the concept stage. And what's nice about this tool is we're able to run through and see, with our design, how many bottles could we run per hour? Or could we have multiple sized bottles running per hour? Is that gantry head, is it going to be able to keep up? What's really neat about this is if you know your CAD, you could see that there's really nothing to this in the CAD modeling world. There's really nothing there. At this early stage, you're able to run concepts and see, is what you're thinking, is it actually going to work? And what's cool about this too is, at least for this portion, the automation engineer, they could actually start writing their code. So how does the tool work? Well, let's look at the various roles. So the first, electrical engineer, what are they doing? Well, they're defining electrical parts. They'll say where the sensors go, what type, how are we routing the wires, what type of motor, and so on. Now with NXMCD, how does it change their job today? Well, it doesn't. Every electrical engineer I've ever worked with, they'll just stand over your shoulder and kind of point at the screen about what they want. Now there is an enhancement, and that's that they're able to test the size of sensors, motors, anything virtual. They're able to do it ahead of time, and they're able to do it virtually. Let's look at the next role, the automation engineer. So what are they doing? Well, they're writing this code. It could be they're using ladder logic. They're defining what happens and when. So in this case, when's that plunger going to move? When does a conveyor start or stop? The big change that they have from today is the location of the commissioning, because they're able to do their commissioning not in some far-flung corner of the globe, but rather they're able to do the majority of it right in their office. The enhancement is that they can test the code ahead of time. And instead of instead of real crashes, virtual ones. Lastly, the mechanical engineer. What does he do? He designs the physical parts. And just looking at this model, you can see he has a lot of work yet to do. He's got to build the rest of the things around this. Some of the changes for him, though, is he's going to have to add these physics properties to the models. So he's going to have to add physics to these bottles, make that conveyor, make it move. He's also going to have to add movement to the gantry head and sensors. So he does have a little bit of work that he's going to have to do. Now you might think, if you're the mechanical guy, wait a minute, I'm not sure I like this. This looks like it's just a bunch of additional work for me. Well, there is some extra work for sure, but it does save in a lot of other areas. And it's not just saving the automation engineer, and it's not just getting the product out the door faster. Let's see how it affects you individually. So the first is with concepts. If you just look at this little model, it's just a couple of lines. It's just a couple of sticks. And yet we're able to get a load curve on here. So we're able to actually add physical properties, test our concept on just a couple of lines. You don't have to get here to know if what you're going to do, if it's going to work. Another example is cam curves. Now, cam curves are where you're taking multiple pieces of movement, you're trying to transfer that motion. These are difficult to do. But with NX MCD, it really becomes easy because it's automatically generated. So something that typically takes a lot of time, no problem. Let's actually take a look at this tool, NX Mechatronics Concept Designer. So that's what I've got up on my screen right now. Now just to show, I'm going to hit play, and look at that. Okay, nothing's happening. So what I need to do is I need to add some physics to my model. So the first thing I'm going to do is I'm just going to take this bottle and I'm going to make it a rigid body. Basically what that means is I want the physics, I want it to react with this part. So now if I hit play, you can see it just falls to the ground. That's because gravity took effect. I'm also going to make it a collision body. Basically what that means is if this interacts with anything else or comes across anything else, I want it to react. The next thing I'm going to do is I'm going to turn on a conveyor or create a conveyor. So I'll use this transport surface, and I just have this little surface body here. So I'll just choose that. I choose the direction that I want it to go and the speed, 100 millimeters, that's fine. And then also I'll make it a collision body. And we'll hit OK. And then play. So now you can see that bottle, how it's working. Now what's neat is because it has physics, I can actually interact with the model. So I can take this bottle, as you saw, and grab and move it around. So we can let it run through. It looks pretty good. So I'll hit stop. But that's really all there is to it when it comes to adding the physics properties to that bottle. So it's really easy to do. The next thing I'm going to do, though, is I'm going to add a couple of sensors. So I'm going to add what's called a collision sensor to this little line on the side. And then I'm going to say that I want to have a bunch of these bottles running. So I'm going to create what's called an object source. So I'm just going to, for my simulation, say every 5 seconds, I want to have another one of these bottles. And then to save on memory on my computer, I'm going to say every time one of these bottles comes across this sensor, I just want it to go away. So we'll hit OK and play. And just this easily, we're able to add those physical properties. Uh-oh, did you notice that? And let's see how that works. Good, I got rid of it. So we found a little bit of an error here, and that is that plunger, it's just a little bit too far forward. It's nice to be able to see that right now instead of when the machine is being built. And what's cool is you'll notice not every bottle is hitting it, because if you think about the physics, the physical properties on there, it would change. So let's go ahead and hit stop. In just a few moments, what were we able to do? We're able to create a conveyor, create the physics properties for this bottle, and add a sensor. Certainly, there's more work to this, but just so you can get an idea that we're not talking about adding gigantic swaths of time to our project. Now, how far can we take our simulation? Well, we can go quite far. What we're looking at here is a detailed simulation. You'll notice on the right, we have this sequence timer. So we're just telling the machine to work, but we're just using NXMCD for everything. So at this point, it's not talking to a PLC. But with this, imagine giving this kind of file with this timing chart, giving that to the automation engineer. It's just something that's going to help. But the next slide is actually going to show the virtual commissioning. So here we've got our NXMCD, but then we're going to turn on a virtual PLC, and that's called a PLCSim Advanced. So we'll get that virtual PLC running. And then what we're doing is we're linking up the tags. So you know, if you're writing your code, you've got your tag table. We just want to link those up to the tags in NXMCD. So here on the bottom, we've got our virtual HMI. And as they press on a button, left or right, you notice that the gantry head, it moves, or the belt, how it turns on and off. It's just like if you were standing in front of the real machine, holding the real HMI in your hands, except we're doing it all virtually. You're able to test the code, test the machine, test everything to make sure it's going to work as designed. Or as we said in part one, so that it will not fail. And so we're just going to continue to run it, and then let's just speed it up a little bit. What's nice about this is you can do what-if scenarios to see what would happen if it went really slow, or what if you took it too fast, and so on. Or what if the plunger went out? Now this is really cool. The door opens. If you were holding the HMI in your hand, you would expect to see a warning sign. That's how accurate and how precise virtual commissioning is. It's just like the real thing, just virtual. So go ahead and keep running our simulation. What if you hit the e-stop? Well, you would expect to see that pop up, that warning. Again, virtual commissioning, it's the same thing, it's just virtual. So you could say it's just a little bit safer. So what are some of the benefits of NX Mechatronics Concept Designer? Well, what we find is that you're able to get to the market up to 30% faster. And there's a number of reasons for that. One, the automation engineer, they can get started at such an early stage. But you can also use this tool from the concept all the way through the detail designing. It helps the engineering team to actually be a team. because mechanical, electrical, automation, they actually can work together. And then the icing on the cake, virtual commissioning. Imagine not having to worry that your machine is going to fail the day before you turn it on for your customer. Imagine what that would be like. At the beginning of our presentation, we talked about the questions that I'm personally hearing as I talk to different companies. The first one, nobody wants to travel, not with this pandemic. How does MCD help? Well, virtual commissioning, it makes it where instead of being on site on some far-flung corner of the globe for weeks, you may only have to be on site for a couple of days. Or the ability to win more business without hiring a bunch of folks. Well, MCD cuts down the design cycle by 30%. So think about that, 30%. If you could get to the market 30% faster, what could you do with that extra time? Or our customers, they're just constantly demanding more things, more flexibility. Well, with mechanical, electrical, and automation, with them all working together, and even at an early phase, no more waiting. So you could say to your customers, bring on the flexibility. And then for the automation engineer, these poor guys and gals, they just keep getting squeezed with their timelines. How does it help? Well, instead of waiting until the machine is completely built or just about built, you can start writing your program and then see the results right away. Or the risk. Instead of having real risks, real failures with actual commissioning, virtual commissioning. You can have all of the virtual crashes that you want, and it doesn't cost a thing. So NX Mechatronics Concept Designer, embracing the digital twin, that's what we're talking about today. And hopefully you've been able to see the benefits of this tool. Now we went through this rather quickly. So we did this in 2 parts. And again, you can scan here to watch part 1 or to see other webinars that we're going to have. But would you like to get a little bit deeper into the weeds? Would you like to learn a little bit more about the ROI of MCD? Then please feel free to contact us at our email address, sales@goplm.com. I'd like to take this time to thank each and every one of you for your time and attention. Have a great day and stay safe.